Hi everyone, my name is Zafan, and today I wanted to cover exact values of trig ratios. So if you've been watching the past two videos, I was actually on my iPad, and the quality on the video was not the best, so I apologize for that. When I was editing the videos, the trigonometry videos, they were just they were bugging out in the video editor. So I'm just back here on my whiteboard where I'm more comfortable because editing is not my strong suit sometimes. So I'm up here, and today I just wanted to continue that discussion about trigonometry with angles that are greater than 90 degrees and just a little bit more advanced trigonometry in general. So today I wanted to cover exact values of trig ratios. So I have in front of me a few problems that I found, and I'm just going to go over how we can solve them. Okay, so let's say you had a question that had cosine of 120 degrees. Please excuse my handwriting. I have to say that every video because my handwriting is not the best. So let's say we had cosine of 120 degrees, and we wanted to find the exact trig ratio for this angle here. So the thing here is having a unit circle really helps, but sometimes you won't always have a unit circle with you, and if you don't, well, you always have to draw a sketch. So I do have the unit circle in front of me just for time purposes, just so I don't have to go ahead and draw the triangles for the ratios. But okay, back onto the question, we had cosine 120 degrees. So 120 degrees is something we can't compute for right off the bat. We always have to draw a sketch when we have something like this. So let's say I had my x and y axis. Alright, so 120 degrees is above 90. So here we go. So this could be 120 degrees, right? So I can't compute for cosine of 120 degrees, but I can compute for the related acute angle here, which I always call beta, right? So what is beta in this case, right? Beta in this case is 180 minus 120. So why is it 180 minus 120? Well, because this entire region here is 180 degrees. I've only went 120 degrees, so I only have beta degrees left, which is just 60 degrees, right? So instead of computing for 120, I will compute for cosine of 60, but I will have to change my answer, and the reason I have to do that is remember the cast rule, C-A-S-T. All my trig ratios in this region are going to be positive, thus the A. All my trig ratios here are going to be positive except sine. So, oh, my bad, messed that up. All my trig ratios in here are going to be negative except sine. All the trig ratios in this quadrant are going to be negative except tangent. All the trig ratios in this quadrant are going to be negative except cosine. So sine is only positive in this quadrant, and we're computing for cosine. So whatever we compute here will change the answer to be negative. Okay, so cosine of 120 degrees we don't know how to compute, but we do know how to compute cosine of 60 degrees, right? So let me just take out the unit circle and see cosine of 60 degrees. Where is it? Cosine of 60 degrees is 1 over 2, right? So 1 over 2 is cosine of 60 degrees. But again, we don't want cosine of 60 degrees, we want cosine of 120 degrees. So cosine of 120 degrees is going to be the same thing, but I have to put a negative in front. A negative in front. Because it's in this quadrant where only sine is positive. So if you have an angle that's greater than 90, go ahead and draw a sketch, see which quadrant it falls in, compute the related acute angle, so compute that, and then after you've computed the related acute angle, just change the sign depending on which quadrant you're in and what trig ratio you're dealing with. Okay, so this was one example. Let me erase everything here and we can do another example if I have one in front. Great. Okay, so what if we wanted to compute cosecant of 240 degrees? So now this is a whole new story because now we have cosecant. This isn't even a trig ratio that we deal with normally, right? So we first have to remind ourselves of what cosecant is. If you remind yourself, you would probably remember that cosecant theta, so whatever angle that is the opposite of sine theta, right? We can agree on that. So cosecant theta is the inverse, or the reciprocal, not inverse, my bad. Inverse trig functions are completely a different story. So reciprocal trig ratio is 1 over sine theta, right? So I can't compute for cosecant, but I can compute for sine, and what I'll do is I'll flip it, right? Reciprocal, I'll flip it, and that will give me the answer for cosecant 240. So what I'm going to compute for is sine 240 degrees, alright? Again, why am I doing this? Because I can compute for sine values. I can't compute for cosecant values without my calculator. Even my calculator doesn't do cosecant. I'll always have to do sine, and I'll take the reciprocal. So what I'm doing, again, is taking sine, and I'm going to compute sine 240, and I'll flip it, and I'll get cosecant, because that is what cosecant is, right? So sine of 240 degrees. Why don't we go ahead and draw ourselves a little sketch of how this would look. Again, if you have a unit circle, you don't really have to draw yourself a sketch because all the answers are on there. You can just go look up sine 240 and flip it, right? You could do that, but if you don't have that advantage of the unit circle, you can always draw yourself a sketch, and I believe teachers prefer you draw yourself a sketch so you just understand how even the unit circle works. So 240 degrees is going to be in this region somehow. I'll just use black for this. So 240 degrees will be in this region somewhere, right? So this entire area will be 240 degrees. So again, I can't compute for sine 240, and before I move on, let me just draw my cast rule, right? Which trig ratios are positive in which region. Okay, now that I've done that, so I can't compute for 240 degrees, but I can compute for the related acute angle. So where is the related acute angle, you may ask? Well, always remember that you get the related acute angle from the x-axis. So the related acute angle is right there. So I'll call that beta. So we're going to compute for beta, and then that will be our answer for sine 240, and we'll make sure we use the cast rule too. Okay, so what is beta in this case, right? Well, this entire length here, so starting from here, if I go up to here, that's 180 degrees, but I'm at 240 degrees, right? So how much extra did I go? Well, I can just figure that out by doing 240 minus 180, which is simply 60 degrees, right? Okay, so I'm just going to erase that. 60 degrees. So beta, we know, is 60 degrees. Alright? So let's compute for sine 60. Again, we'll compute for sine 60, and then we'll switch our signs depending on the cast rule. Okay? So what is sine 60? Sine 60, I will use my unit circle, and I'll figure that out. Sine 60 is square root of 3 over 2. Sine 60 is square root of 3 over 2. So what is sine 240? Well, sine 240, again, let's look at our cast rule. So cosine is positive here. All of them are positive. Only sine is positive in this region. Only tangent is positive in this region. So sine of 240 has to be negative, right? Because only tangent is positive. And I know what sine of 60 is, which is the same as sine of 240, but I'm just going to write negative square root of 3 over 2, right? Because that is what I am computing. Okay, so now that I have sine of 240, I can actually go ahead and get cosecant of 240 degrees because I have sine. So all I need to do to get cosecant of 240 degrees, let me just rewrite that here so you can see it. So cosecant of 240 degrees is simply 2 over square root of 3. So, 2 over square root of 3, and that's a negative. So it's negative 2 over square root of 3. So how did I get that? Well, first of all, I realized that cosecant is the reciprocal of sine. So first I turned it into sine 240, and I computed that, which was negative square root of 3 over 2. Well, how did I get that? Well, I computed sine of 60 by getting my related acute angle, which was square root of 3 over 2. Using the cast rule, I determined that it was a negative, right? Okay, so now that I had sine of 240, all I have to do is flip the number, which is negative square root of 3 over 2, and I flip it, I have 2 over square root of 3, and a negative in front. And if you want to be fancy, you can get rid of the square root on the bottom, and you'll have 2 square root of 3 here, and it'll still be a negative. Alright, so again, if you see something with a reciprocal trig ratio, always switch to the trig ratio you know how to deal with, and then do your whole cast rule and your principal angle and beta angles. Okay, so hopefully that helped, and you know how to compute 4 exact values of trig ratios, and again I'll post some more videos on trigonometry in the upcoming future. Hopefully that helped, and again, please subscribe if these help you. Thank you.